Hello, everyone. Thanks for joining me today in this session. DevSecOps with IoT. Is it a myth? Well, we'll see. This is Neil Mitra. I'm a specialist solutions architect on IoT. I work with customers worldwide, have been working for AWS close to 4 years now, based out of New York City, and super excited to be in front of all of you today. So we have a lot to cover today. I guess you care about DevOps or security or IoT or everything, and that's why you are here. So you're probably a DevOps engineer or an architect, a security practitioner, or just love the space. So that's awesome. You're at the right place at the right time. We'll start with a quick insecurity of things to help you understand why IoT is complex. Then I will introduce you to different AWS IoT services in case you are not familiar. And we will get into the weeds, focusing on edge computing. Specifically, how do you develop, operate a new generation of applications at edge securely in an agile fashion? That's going to be the goal of this session. So without being an embedded developer, how do you bring the agility that you have in the cloud today? Finally, I will try to show you a quick demo and get you going to your next session with some resources. Sounds exciting? Let's get started. If you are here, you already know the potential of IoT. IoT is being adopted across all different verticals: connected home, industrial, agricultural, financial. According to IDC, worldwide technology spending on IoT will reach more than $1 trillion in next few years. That means as developers, you will have a lot more to code. And we can see some of us today, part of our lives, we are surrounded by IoT devices like an Alexa monitoring my home. Hope she's not listening. To drones delivering packages. IoT is everywhere, but being everywhere is a problem as well. And that's the reason, you need to understand a lot of scenarios that you need to cover when you are building this kind of applications, because your security perimeter is getting larger with the physical devices interacting with you. Such as, what are the scenarios? Denial of service, where IoT devices can prevent access to legitimate web services, or LTE, where hackers can use IoT devices to bypass the perimeter security and access critical resources. And these threats are not going anywhere anytime soon. So why is that? Because IoT solutions are complex and multidimensional. So think of these different layers. You have the edge layer. This is where you onboard, operate, and manage all your devices or assets. Then you have the communication layer, which handles the connectivity, message routing among devices, between the devices and the cloud. Then you have the ingestion and analytics layers. This is where all the disparate data streams gets aggregated, created by your devices to help you analyze, visualize, perform machine learning to drive your business outcomes. And finally, you have the application layer as well. This is where you build different kinds of applications, like user applications to enable your users like us interacting with, Alexa, or mobile applications to start your thermostat or set a temperature and whatnot. You also have management applications. That means you are creating a set of applications for your field technicians to create and operate your device and diagnose them from time to time as needed. So with all these layers, it's very difficult to identify different issues and engage to mitigate them very quickly. So now the obvious question is, how does AWS help customers here? So we have tried to simplify this architecture, this multidimensional architecture, into standard 3-tier architecture. And learning from the experience of our customers in the last few years, we had been building different services for different use cases across these layers. So on the device layer, we have services like IoT Device SDK, which is an SDK that you can use for different IP-connected devices, like your mobile phones or other devices, which can directly talk to a cloud endpoint. And we offer this in different languages, like Node.js, Java, Python, Go, C#, you name it. Then there is Greengrass as well. With Greengrass, it brings a lot of edge computing capabilities on the edge as a gateway. It can act as a very powerful appliance and connect you to cloud services, different cloud services as needed. Then you have FreeRTOS, which is an operating system for microcontrollers. So if your devices are really resource constrained, like the sensors or the fitness trackers, that's where you use something like a FreeRTOS, which has few KBs of RAM maybe. On the middle layer, we have built control services. So starting with IoT Core. With IoT Core, it gives you a managed platform. It's a gateway to support billions of devices and trillions of messages. And it can route all these messages using a rules engine to backend services as well. And now you have billions of devices on the field. You need to ensure that you are managing them properly. So IoT device management helps you to organize and manage your devices, including doing OTA upgrades, patching, and new firmwares. But that's not the end, right? You have organized your devices. How do you do that securely? So that's where IoT Device Defender helps you, which enables you to continuously audit your IoT configurations to ensure they are not deviating from the security best practices throughout their life cycle. Just think of smart switches. It can sit in my room or in my apartment for next 10, 15, 20 years, but I don't want them to be compromised even 10 or 15 years from now onwards. So how do you think about those kind of scenarios? IoT Things Graph, how do you build all these kind of IoT applications quickly, rapidly? So that helps you build a prototype really quick with different web services using a drag and drop mode. And the top layer is a data layer. This is where we have built services like IoT Analytics, which helps you to collect lots of time series data from all these devices and store it in a time series optimized data store, on top of which you can run SQL. Everyone loves SQL, right? So you can run complex SQL, simple SQL, you can do visualization with BI tools, you can do machine learning on top of them. There's a lot of things that you can do. IoT events, it's very easy to monitor one sensor, but when you have hundreds and thousands of sensors and you need to detect issues with your sensors, how do you do that? That's where we have built a service, IoT Events, which helps you to monitor equipment and fleets of devices for failures or changes in operation and trigger alerts for you. IoT SiteWise, it makes it easy for you to collect and organize data from industrial equipment, which might be talking industrial protocols like OPC UA. So that's a lot, right? I don't want to overwhelm you. And in this session, we are only going to focus on IoT Greengrass, which is marked on red on my screen. But to get the point, what we are trying to do is remove the complexity of implementing IoT into the business. We do the undifferentiated heavy lifting of managing the infrastructure so that you can focus on the business outcomes. And millions of customers have been using these services every day. A quick peek into some of the customers like Vizio. They have built their entire line of smart televisions and sound bars. They have millions of devices on the field using IoT Core. If you think of a customer like iRobot, if you have a Roomba vacuum cleaner, they have mopped more than 500 million square feet of floor space, and they use IoT Core. If you think of a customer like Pentair, they provide beer and water filtration system to industrial brewing customers. So with IoT Greengrass, they ingest a lot of operational data to improve their operational efficiency. So now let's get into the weeds with that background. I hear this question often, Age, is this something new? We thought cloud computing solves all our problems. Well, the first generation of enterprise applications were built with focus on people, like CRM applications or ERP applications. And we often refer to them now as Internet of People applications. Today, we are talking about building applications for the things, Internet of Things applications. So thus, we need a decentralized system, which is closer to us, the people, serving our needs. Think of Alexa or our mobile phones. Thus, this concept is not new, and we see a lot of implementations today, though. So how does it work? In simple terms, you have your devices like thermostats, light bulbs that exist in your home network. It connects using Wi-Fi, Bluetooth, Zigbee, Z-Wave, and whatnot, and is often managed through a local gateway. The local gateway, in turn, does a lot of things. It can do a command control, like change the temperature of my room, message routing, different kind of data aggregation, and connectivity to the cloud as if needed. And once the data is pushed to the cloud to IoT Core, you have all the goodies of cloud with its economy of scale, with different value proposition, like you can do device management, you can do all the auditing, you can do data processing, you can build serverless applications, you can do machine learning and whatnot. So the obvious question is, how do I develop on the edge? Well, if you think traditionally, you have to be an embedded developer using low-level languages like C and C++ and whatnot. And our customers like you asked us how you can practice DevSecOps patterns with edge devices and edge applications as well. For example, you might have a hardware like ESP32, which is a microcontroller, or you might have an NVIDIA Jetson, which could be a microprocessor. On cloud, it's very common for customers like Amazon do thousands of deployments every week, or maybe hundreds of thousands, I don't know. Can we do something similar with edge applications as well for you to continuously innovate and improve the customer experience with their hardware and with their solutions? So let's see. And that's where Greengrass comes to the play. It's a comprehensive edge solution that brings local compute, local messaging, data caching, sync, machine learning inferencing, OTA capabilities to edge devices. It can act as a very powerful device that can work in a completely offline mode. I repeat, it can work in a completely offline mode. That means whenever it is disconnected to the cloud, and there could be different scenarios. Think of a automotive. It is in a no network zone, but everything that is happening in that self-driving vehicle or autonomous vehicle need to continue without the cloud connectivity. How do you do that? You need a solution that can work in a continuously disconnected mode. That's where Greengrass can help you. And of course, it can also act as a gateway to thousands of devices behind it and talk to the cloud as necessary. So it's an extension of the cloud to the physical world. But it's a software. That's the beauty of it. It can run on any hardware, which is x86 or ARM architecture. It just needs one core of CPU and 128 MB of RAM. That's it. You can give as much as you want, but at the minimum, that's what is required. You can run this on different flavors of Linux, such as Ubuntu, SUSE, Raspbian, or for non-Linux platforms, you can run it as a Docker container. So for our Docker lovers, this is awesome, right? So on top of Greengrass, you can deploy your code through Lambda functions or Docker containers. And that changes the entire game, because now you can use Java, you can use Node.js, you can use Python with Lambda. If you have never used Lambda, it's our serverless offering. That means you just do the coding and you upload to the cloud, and cloud does everything. Now that cloud capability is brought to the edge as well. So you can do all your coding on the cloud, and then you can deploy all this to the edge. And we'll see how. The same thing for containers as well. So now, since you can develop in all these different programming languages like Java, Node.js, Python, or anything that can be Dockerized, you do not have to be an embedded developer anymore to build this new generation of edge applications that is changing our lives. So now let's talk a little bit more into the technology. What is Greengrass? What are the different components it has? The first definition that you need to understand well is of Greengrass Group. Think of it as an overarching package that contains all the other resources in very simplistic terms. So Greengrass Group has a Greengrass core. This is like the brain of the software. This is a daemon that will run on the Linux environment or on the Docker environment and do all the orchestration for that software. Now, now the core will also interact with other components like the Lambda functions I just mentioned, or the containers, or the subscriptions, which are essentially routing rules for all the messages that is required to be routed on the edge itself. Then you have the connectors, and the name is self-explanatory. It connects to different AWS services or third-party services, so you do not have to code for that. And finally, resources. You can push different kind of resources, like machine learning models, like different kind of secret managers, different kind of local ports, like the USB ports or the serial ports or the cameras that you need to access. using Greengrass as well. So what you do, you build all those resources onto the cloud, you create this group definition using console or CLI or API. There are different ways you can do it, and finally deploy it over the air, and it goes to the edge. Now, how do these components work in conjunction? Very common question. So devices can communicate to other devices with Greengrass. And when I say devices, think of it, Greengrass is, let's say, the gateway, and behind the gateway, you have multiple thermostats, or a light bulb with a thermostat and something else. And they need to probably communicate to each other directly for some reason. So they can do that, and Greengrass will manage that orchestration. Or you do not want the device to communicate to each other directly. You want them to go through a routing logic. That's why you can put a Lambda in the middle, and Lambda can do a lot of local data processing, data filtering, and it can make the decision whether the data needs to go from source A to source B. You can also run Docker containers, as I say, on top of Greengrass. So you can port any existing application that you have today. So you might have a lot of existing investments. You do not want to recode, and that's fine. So you can bring all those applications that and run it on top of Greengrass. And there are also the scenarios where you do not want to fit into that Lambda paradigm, or you have a programming languages that is not supported by Lambda, that is, which is beyond Java, Node.js, or Python. You might have something like a MATLAB. What do? You can Dockerize that as well, and then you can associate to Greengrass and push it to the edge. So how does it work? What do I do in the cloud, and what do I do in the edge? I'm confused. Understood. So let's see. So what you will do is you will continue to use your CI/CD pipeline. You will build your applications in the same way you do today, whether it's a Docker application, whether it's a Lambda on the cloud. So you do all your code coverage, you do unit testing, you do SIT. That everything that happens today in your world can exist as it is. And once your code is verified and is checked into the final branch, from there you can take all those images and associate it with Greengrass. Now your code can come from different kind of repository. It could be Docker Hub, it could be a private Docker repository, or it could be a container registry provided by AWS. And then Greengrass, having all these resources associated with it, can deploy it over the air when you click the button or trigger the script. And you can do any number of times. That's the beauty, right? You do not have to think anymore that this is my hardware and this is outside the cloud and the data centers. I do not have access to it. That is true if you do not have connectivity. But if you do have the connectivity, you can deploy your security patches, code, configurations as many times as you want. And that brings a whole agility. And guess what? Like the edge community is growing by leaps and bounds. So you can get different compatible hardwares, different solutions, the community support for production grade deployments as well. With that, let's switch gears and talk about security. Security is job zero at AWS, which means everything we do starts with security. But there are two very important concepts that you should remember. The first one is shared responsibility model, which states security and compliance is a shared responsibility between AWS and the customer. AWS responsibility is security of the cloud. That means we are responsible for protecting the infrastructure that runs all the services offered in AWS cloud. The infrastructure is composed of the hardware, the software, networking, the physical data centers that runs the cloud services. And AWS is responsible for managing the hypervisor down to the data center. But your responsibility as a customer is security in the cloud, which means customer responsibility is determined by the cloud services that you select. That might include the amount of configuration work that you must perform as part of your security responsibility. You might develop your applications. You will bring your own data. We give you all the tools, all the best practices, but at the end of the day, it's your application, it's your data, and you need to ensure that you are aligning to those practices. So how does it extend to IoT? Well, with IoT, we do not have the control to your physical device. It's not in an AWS data center. It's somewhere out there in New York or Singapore. So as a customer, you are responsible for the physical component and interface security of your devices as well. We help you along the way, again, with all the different best practices, tools, capabilities that makes it easier for you so you are not alone. But at the end of the day, you need to make those well-informed decisions and align to those best practices. So with those in mind, let's talk about Greengrass a little bit. So Greengrass devices looks like this. On the left, it will have all the components that you have seen before, but for security, it does a mutual auth using X509 certificates. So you need to ensure first that all your certificates and keys are well protected. All your private keys are well protected. So that's where the recommendation is you should use some kind of a HSM solution, use a PKCS interface, and retrieve the keys in an ephemeral way from time to time. It should not be sitting on the file system in clear text, right? And then when Greengrass as a gateway talks to the cloud, it uses TLS encryption as well to send all the messages. So your communication is protected end to end when in transit. Okay, so what happens on the cloud? That's on the edge. So on the cloud, every Greengrass group, and I will show you in the demo, every Greengrass group is associated with a role. So it's a IAM role, if you're aware of identity and access management, that authorizes IoT Greengrass to access resources from AWS services on behalf of the device. This makes it possible for Greengrass to perform essential tasks, such as retrieving your Lambda functions, interacting with other services, and whatnot. And with all the applications, whether it's Lambda or container on the edge, how do you manage the configuration, the endpoints securely? So not just the keys. What about the rest of the stuff? That's where Greengrass Secret Manager helps you as well. And finally, you can create security profiles with IoT Device Defender, which is our security service in the cloud, and that extends to the edge. So you build a security profile that can capture device-side metrics and cloud-side metrics. So you can collect metrics like packet size, bytes in, bytes out. With the cloud, you can measure like the auth failures, increase message size, and thus you can continuously audit your IoT workloads that spans from the edge to the cloud. And you can even build an automated mitigation pipeline. So DevSecOps pipeline for anomalies that is detected on the edge and it's kind of mitigated in near real time. If you went to reInvent, you might have seen our shuttles, and you have used that probably from going from one resort to another resort. It's our yearly conference, by the way, for people who are not familiar with reInvent. And what we did here, you can see on the picture, we had Greengrass in the middle on top of an Intel Logic Supply hardware, which is collecting all the different camera data, video data, and showing it not only in a local dashboard, but also sending the data from time to time to the cloud so you can access it from your mobile application. What is my wait time for the near bus? Okay, so we talk about development. So you can build all these Lambdas, all the containers, you can deploy it onto the edge in an agile fashion. We talked about the security on the edge, onto the cloud. And now, what about the operations? Because technology fails all the time. So it's important for you to monitor and operate your workload securely as well. How do you monitor your fleet of devices? So AWS IoT and AWS as a whole gives you different services to monitor your workloads. Example, events are generated by the device registry when you create new things. In the data plane, you can collect different logs and matrices using AWS CloudWatch, which is our monitoring service. For the control plane, if you need to have all the API logs, you can access that as well. We give you different kind of operational dashboards out of the box, and you can create your customized version as well. Now, you're doing all these operations, then how do you send it to the devices? Well, that's where OTA helps. And OTA is not just for one device. You can have bulk updates to all your devices that is on the field. Although you should consider deployment velocity, like 5% of my fleet is successful. Now let me do the 10% rather than doing a big bang. Okay, connectors, we touched upon it lightly, but as the name says, you can connect to different services with a simple configuration, whether it's Device Defender that we just talked, CloudWatch, or third-party services as well. Twilio, Splunk, ServiceNow. If you have those part of your enterprise, you can easily connect them from the Greengrass without writing a piece of code to the solutions as well. Okay, so seeing is believing. So I want to show you what I have been preaching so far. So you can see this edge to cloud architecture where there is a sensors and a lot of data is being simulated, and it is going through Lambda functions on the edge. So the left side of the screen is all Greengrass, and it will be on in the physical world, in the real world. This is the device. And on the right side, you see the cloud. That's where the data is being sent from time to time to its data lake for different other purposes like analytics, machine learning, and whatnot. So what I plan to show you is how we can automate this entire solution using DevSecOps principles. So how does it work? Let me quickly show you. So you have the link to GitHub, and you can play with this on your own. But very quickly, the only thing that you need to do, you need to essentially clone a Git repository, and then you need to run an npm command and do a CDK deploy. And what that will do for you, it will create a CloudFormation stack. And a CloudFormation is essentially a template. It's infrastructure as a code where all the resources are defined, starting from S3 and Greengrass and all the components that you see in that architecture from edge to the cloud is stored in this template. So one template, you deploy, boom, your end-to-end solution is running. Now, in the real world, you have to do a one-time setup of configuring your device because it will come from the manufacturing facility versus a simulated world, which I'm going to do it now. But after that, you will do the same process that I show you here of automating your end-to-end resources and finally deploying it over there. So with CloudFormation, this stack is created. In the interest of time, I created it for you in advance, and it creates different certificates. It gives me different endpoints that is being embedded onto the device as well. And then on the IoT console, now you see Greengrass as an option, and this Greengrass group is created. And with Greengrass group, the different concept that was explaining earlier, like you have different routing rules that we call as subscriptions to ensure that the data is being communicated from one place to the other. You have different lambdas. You can see I have multiple lambdas here, as was in the architecture as well. There are different other kinds of resources I have not used much here, and connectors as well, because I have also deployed Docker application deployment connector. So with that, the demo is kind of running here that you can see. This is a console. On the left side, you can see that my devices are storing all the certificates which are needed for the mutual auth from Greengrass to the cloud. Now, it's in the file system. That's because it's a demo. But in the ideal world, you will have a hardware, which will have an HSM, and that will store your private keys and certificates. The configuration will look like this. This is what the Greengrass software uses to talk to an endpoint and perform different operations on the file system as well. And finally, at the bottom, you see the log of data being sent from the edge to the cloud. Also, there is one more application here. Let me move this guy. Okay. This is the Docker container console that is running locally. So web server running locally. So if you have applications on the edge, you will probably have dashboards as well, and you want to run the containers locally. So this is that view. And finally, on the cloud side, the data is being streamed from the edge to the cloud to different services like IoT Analytics, where you can see a real-time review of all the SQL queries. And also, there is Kinesis Analytics, where you can do different kind of anomaly detection that you can see here. So wrapping it up, summarizing, what I showed you from the edge to the cloud, you have different components on the edge running, starting from Lambda and containers. All this data is being aggregated and finally pushed to cloud, where different services like IoT Analytics and Kinesis is processing the data again to store into a data lake, which is finally consumed through QuickSight, which is a BI solution. And get your hands dirty. So the GitHub link is here. You can try it yourself. So what did we learn? DevSecOps is not a myth. You can build an end-to-end automation pipeline for IoT workloads. You can use different kind of tools such as CloudFormation, other CI/CD services. Security features are built into every step, starting from the IAM roles on the cloud, with TLS 1.2 mutual auth for the device to communicate, hardware-specific features like HSM with PKCS integration, and hundreds of security certifications that we have more than anyone else for you to manage and operate your devices at scale. Now, I often hear this question, how do I learn more about AWS IoT services? We have developed a training library, so you can take these free trainings either in AWS training library or on the edX.org site as well, which also gives you a certification if you pay them. And then we have built all these different kind of cool hardwares for you to play with. Like we have the depressor, we have the deep lanes that you can play with. If you do not want them, you can always start with a Raspberry Pi. And for production grade applications, production grade devices, we also have a device catalog with partners such as NXP and Microchip and Qualcomm and all the big names where you can go and choose your preferred vendor. With that, the world is changing more than ever. Today, we need to run our businesses and life using technology as enabler. And as a developer, we have a lot to do. As a builder, we have a lot to do. And I can't wait to see what innovative IoT applications you will develop in the future using Edge and cloud. It's just day one, guys, and there is so much more we have to do. We want to help double your experiments, double your inventiveness, as your success will truly make the whole world successful. With that, thank you, stay safe, and take care.